Last video it was not that much clear, so I thought I should once again repeat the entire lecture which I have been posted day before yesterday. So friends, I was talking about various operations like microfiltration, ultrafiltration, reverse osmosis, then nanofiltration and the gas separation. So these are the operations which are performed by using membrane. So membrane separation, it comes under advanced separation processes, which is non-conventional method. I know it is just similar to the filtration, where in filtration we are using filter medium, and here we are using a membrane. So what is the basic difference between filtration and membrane separation? It is very simple. So have you heard about the selectivity? Selectivity is the term where we can separate a desirable or desired fraction of the solvent. So by using morphology of the membrane, we can separate various types of ingredient from the mixture. So that is a specialty. Now nowadays this technique has been reached at everyone's doorstep through water treatment units. So reverse osmosis is the very common process nowadays. You can see any kind of purifier like Kent, or it may be I guess there are a lot of companies which I can enlist, like Eureka and Ion Exchange. This is one of the company who is serving in this sector to treat the water by using ion exchange. So let me take you towards the comparative study for the all membrane separation process technique with respect to membrane type, their pore radius, then the method of construction which is used for the membrane, process driving force, and at last the application. So friends, it is very simple that the application of each process is very simple, that to separate the ingredient of the mixture. Though the type of membrane would be differ, pore radius would be differ definitely. The material of construction, that is membrane material, would be different, as well as the process driving force will also differ, but the objective of the process is same, that is a separation. So as per this microfiltration concern, let me tell you the membrane type used for such a advanced separation process technique are symmetrical and microporous, where the size of the pore, that is the pore radius which is called, is 0.1 to 10 microns. The material which is used to prepare the membrane for the microfiltration might be cellulosic nitrate or acetate, polyvinylidene difluoride, that is PVDF, polyamides, polysulfone, PTFE, metal oxides, etc. So these are the materials which are used generally to treat the microfiltration. The name itself indicates microfiltration means we are going to separate the microorganisms which are present into the water. Generally this technique is used to treat the wastewater or the muddy water or the natural source of water which is to be filtered for drinking purpose. Now as per the driving force concern, a hydrostatic pressure difference would be the driving force for this process. So the applied pressure might be in range in between 10 to 500 kilopascal, where the application is sterile filtration, and the clarification. So friends, with help of such various parameters like membrane type, pore radius, membrane material, process driving force, and the application, easily we can distinguish each and every operation which is related to the membrane separation. Now heading towards the ultrafiltration. You might aware about the couple of practicals we have been undergone, that is the separation of the sugar solution and separation of the milk solution. So we have been used ultrafiltration process for both practicals, where the membrane type is asymmetrical and microporous. Now see, for the microfiltration we are using symmetrical membrane type, where in ultrafiltration we are using asymmetrical membrane type, which is also microporous, like in microfiltration. But here the range is somewhat different. There is a slight difference in the pore radius, that is the 1 to 10 nanometer. 1 to 10 nanometer. If you will take a glance on the microfiltration size, membrane size, it would be the 0.1 to 10 micron. I'm talking about ultrafiltration. The pore size is 1 to 10 nanometer. Now let's move towards the membrane material. See, always keep in mind, membrane material plays very important role for any membrane separation process. The membrane should be able to withstand the pressure which is applied for the process. It should not get teared. It should not get away from the process, where a mixing of feed and the separated solvents can be takes place. So as for the ultrafiltration concern, I was talking about a membrane material can be used as polysulfone, polypropylene, nylon 6, PTFE, PVC, acrylic copolymer. So these are the family of the material of construction from which we can derive the membrane which is used for the ultrafiltration. Sometimes PAN, that is a polyacrylonitrile, is also used for the ultrafiltration process. Now let's move towards the process driving force. So again, the hydrostatic pressure we are using as a driving force, but here the pressure applied is 0.1 to 1 megapascal, and the end use or the application is separation of macromolecular solutions. As I told you, a separation of sugar solution, separation of milk solution, where we are getting clear water as a permeate, and what are the solid part would be retained on the upper side of the membrane. Now moving towards another technique, that is the gas separation. See, gas is also comes under fluid. Separating gas from the mixture is really very crucial and critical job. Here again we are using asymmetrical and homogeneous polymer as a membrane type, whereas as a material of construction concern, polymers and copolymers are used. Generally the density of gases are very less, that is why it is not that much essential to worry about the thickness of the membrane. So as per the driving force concern, the hydrostatic pressure and the concentration gradient, which is used generally actually for mass transfer purpose, is used, and the separation of gas mixtures can be achieved as an application by using these such membranes. So nanofiltration, that is not part of our syllabus, but I will just take a review regarding it. So the very thin film membranes are used for the nanofiltration, and the cellulosic, acetic, and aromatic polyamides are might be the deconstruction of the material for the membrane preparation. And if you will see about the pressure ranges, it is very high, 9.3 to 15.9 bar. It's not a joke. You should have such assembly to withstand the pressure, and then by using such a membrane material, membrane type, and the varying pressure, we can remove the hardness and we can achieve the desalting. I told you uh, recently our honorable prime minister, they have been visited to the Israel. So there Netanyahu, he has been shown the portable units of the uh, RO as well as the nanofiltrations. So generally, Israel is using RO filters for getting water from the seawater. That is a desalting process is taking place. So in such operations, such techniques can be used. Uh, Easily you can remove the salts which are present into the water by using such a techniques. Now, I told you friend, in second year itself, myself has been taught regarding various processes in heat transfer by using various types of flows. So basically, for conducting any process, you should have various type of flows like co-current, or it may be said parallel flow, counter current, that is the flows are in opposite direction, and completely mixed flow where the stream is totally mixed upon the membrane, and cross flow. Cross flow is nothing but simply I can say the example of the our condensers of the refrigeration unit, that is the fridge, where the currents are cross current, the flows are cross current. So what do you mean by cross current or cross flow? It is nothing but allowing the fluid to perpendicular to the axis of the tube. In such a case, I can say also example of the automotive radiators. If you go to the truck, the huge radiators are used. Now they are also obeying the cross flow. So co-current, counter current, completely mixed flow, and cross flow. These are the various types we can discuss about. So these diagrams are quite able to understand you how the flows are coming, and the feed and the permeate is also shown by the various arrows. So these are the ideal conditions or continuous flow which are used to the used in the membrane based the separation processes. Thank you. I hope you have been found this lecture very uh, useful, and as I said, we have been gone through all techniques during our lecture itself, being the syllabus is very selected, very important. I have been shown various videos, and I also elaborated each operations on blackboard also. So I hope this lecture will found you very useful to review the various processes. Thank you.